notice, and this is a typical copyright. We are continuing with the May-June 2018 mathematics syllabus, which runs up to 2027. Just a reminder that the syllabus is divided into 9 sections, as you can see here. Section 1, I have divided into 32 videos, and all of those videos will be made available in their entirety on YouTube. As I said before, this section forms the foundation on which the rest of the syllabus is based. How well you can handle this section will predict how well you will do with the rest of the syllabus. You can then decide after viewing all 32 videos in section 1 if you want to sign up for the subscription channel. And even those videos on the subscription channel will be made partially available on YouTube. So we already talked about the paid subscription. Just a reminder that the math exam has 3 papers. Paper 1, 60 multiple choice questions. Paper 2, an assortment of structured questions. And paper 3, which is an SBA if you are in school. And if you are not in school, it's an alternative to the SBA, which follows similar type of questions. In all papers of the exam, a formula sheet will be provided. Silent electronic non-programmable calculators are permitted in papers 2 and 3 only, not in paper 1, which means that we have one caveat. You will need to know the times tables 2 to 12 if you hope to pass this exam. Now, it is crucial that you know the multiplication tables. I am emphasizing that. This is the one that we are familiar with from way back in primary school. And this is another format of the same multiplication table that you may have seen. Remember also that you need to get some math textbooks. One of the set recommended by CSEC is Volume 1, Mathematics, a Complete Course by Raymond Tulsi. That would be Volume 1. It comes in 2 volumes. Volume 2. Disclaimer. So if you intend to study for and write CSEC Mathematics exam after a year or 2, keep in mind 2 things. You need to know the multiplication table if you don't know it already. And you will also need to buy 1 or 2 CSEC math textbooks. As it relates to schedule of videos, in September 2024, that is this month, I am hoping to produce these 32 videos in section 1. And next month, October 2024, maybe 13 to 15 videos on consumer arithmetic and so on, so that by May 2025, the complete syllabus in video format will be presented. As we said, 32 videos in section 1. We are now at video 3 in section 1, number theory and computation. And of course, we have to go up to video 32 for section 1. We are still on objective 1, distinguish among sets of numbers. We dealt with video 1, sets of numbers. Video 2, even numbers, odd numbers, prime numbers, composite numbers, and square numbers. Now in this video, 1.13, we will be talking about factors and multiples. Distinguish among sets of numbers, video 3, factors and multiples. Now this will not be a long video since we have only 2 things to talk about. Let's deal with factors first of all. Here are the prime numbers from 1 to 100. 2, 3, 5, 7, and so on, right up to 97. Those are prime numbers. It means that they have only two factors, 1 and themselves. That is to say, you can only find two numbers either smaller or equal to 2 that can divide 2 without a remainder. We already know that each prime number, by definition, has only two numbers by which it can be divided without a remainder, itself and 1. So prime numbers have only two factors. Let's take any number that is not a prime number and start to divide it successively by the lowest prime number, then the next higher prime number, and so on, ensuring that each time there is no remainder. So if you take 30, for example, and you divide it by 2, that's the lowest prime number, you get 15. You take 15 and you divide it by the next lowest prime number that can divide it without a remainder, which would be 3, you get 5. Then you take 5 and you divide it by the next lowest prime number that can divide it without a remainder, which is 5, and you get 1. Now, each of those divisors, this 2 here, this 3 here, and this 5 here, is called a prime factor of 30. If we multiply them, the prime factors, that is, we will get back 30. 2 multiplied by 3 multiplied by 5 gives us 30. Now let's set up that last division differently. Like this. We start with 30. We divide by 2, we get 15. Divide that 15 by 3, we get 5. Divide that 5 by 5, we get 1. So the prime factors of 3 are these numbers that you see here on the left. Of course, 6 and 10 are also factors of 30, but 6 and 10 are composite numbers. Normally, we look for the prime factors only. If the prime factor appears more than once, it may only be mentioned once. Example, 40 divided by 2 equals 20. 20 divided by 2 equals 10. 10 divided by 2 equals 5. Notice that 2 appears 3 times, so you will not state it 3 times. You will just say one of the prime factors of 40 is 2, and the other one is 5. So the prime factors of 40 are 2 and 5. Now, if we look at another example, we divide 70 by the lowest prime factor that it can divide it, which would be 2. We get 35. Then we take the next lowest prime factor, which would be 5. We get 7. And then the next lowest prime number, which would be 7, and we get 1. So the prime factors of 70 are 2, 5, and 7. If you multiply 2 by 5 by 7, you will get back 70. One other example, if we take 100, we divide it by the lowest prime number we can think of, is 2. We will get 50. We divide that 50 by 2, we get 25. Divide that 25 by 5, we get 5. Divide that 5 by 5, you get 1. So the prime factors of 100 are these, but remember, if it appears more than once, we will just list it once, are 2 and 5. A factor is a number that divides the given number without any remainder. The factors of any number are finite. For example, the factors of 13 are 1 and 13. The factors of 12 are 1, 2, 3, 4, 6, and 12. They are limited. So the factors of any number is a number that could divide that previous number without a remainder. Now let's talk about multiples. If you multiply one number by another number, the answer is a multiple of the first number. For example, 5 multiplied by 3, you get 15. 15 is a multiple of 5. If you multiply 5 by 4, you get 20. 20 is a multiple of 5. If you multiply 5 by 5, you get 25. This 25 is a multiple of that 5. And of course, if you multiply 5 by 6 and you get 30, 30 is a multiple of 5. In other words, in that 30, you could find 6 5s. Similarly, in this 20, you can find 4 5s. While a number has a limited number of factors, there is no limit as to the number of multiples a number can have. This is your definition from your CXC syllabus. Multiples: the product of multiplying a number by a whole number. For example, multiples of 5 are 10, 15, 20, or any number that can be evenly divided by 5. Note in the example CXC gave above, 0 and 5 are left out. In other words, 0 is not a multiple of 5, even though you multiply 5 by a whole number, which is 0. And 5 itself is not a multiple of 5, even though you multiply it by 1, which is a whole number. So we probably need to modify that definition that CXC gave up there. So remember what whole numbers are: 0, 1, 2, 3, 4, 5, and so on. According to this definition here, if you multiply a number by any whole number, you will get a multiple of the previous number. That's not strictly correct because 0 and 1 do not apply. So, definition from CSEC: the product of multiplying a number by a whole number. So if you multiply 7 by 0 and you get 0, that is not a multiple of 7. If you multiply 7 by 1 and you get 7, that is not a multiple of 7 because you only have one 7 here. You don't have many 7s. Now, if you multiply 7 by 2 and you get 14, in that 14, you have 7 plus 7. And if you multiply 7 by 3, you get 21. In that 21, you have 3 7s, 7 plus 7 plus 7. So you have multiple of 7. And the same thing holds true for multiplying by 4. Now note, 7 multiplied by 0, that 0 is not a multiple. 7 plus 7, which is this case, you get 14. Notice in 14 you have 2 7s, as I said before, and the same thing goes for 21, and the same thing goes for 28. So 28 is a multiple of 7. You have 4 7s in 28. So let's modify CSEC definition. As I said, it's not really correct because it says a whole number here. So multiples: the product of multiplying a number by a whole number excluding 0 and 1. Now let's see how much of this you remember. Over here will be some statements, and over here you'll have to say whether it's true or false. First statement: 3 is a factor of 12. In other words, can we divide 12 by 3 without a remainder? If we can, the answer is true. So that is true. Second statement: 3 is a factor of 5. Can we divide 5 by 3 without a remainder? Answer is no. So this statement here is false. Third statement: 8 is a multiple of 4. If you multiply 4 by another number, will you get 8? And the answer is yes. You multiply 4 by 2, you get 8. So that is true. 4. 8 is a factor of 24. Can we divide 24 by 8 without a remainder? And the answer is yes. So that is true. Statement 5. 15 is a multiple of 5. If we multiply 5 by another number, will we get 15? And of course, the answer is yes. We multiply 5 by 3, we will get 15. So that is true. Statement 6. 4 is a multiple of 12. Okay. A multiple of a number must be bigger than a number. It cannot be less. So if you multiply 12 by 2, you will get 24. And 3, you will get 36. So 4 is definitely not a multiple of 12. So that will be false. Statement 7. 4 is a multiple of 4. Now, this one is very tricky. If you multiply 4 by 1, we will get 4. But that is not a multiple of 4. We have to multiply by at least 2. So this statement here is false. Statement 8. 2 and 3 are prime factors of 6. Okay, can we divide 6 by 2 without a remainder? Yes. Can we divide 6 by 3 without a remainder? Yes. Are these prime numbers? Yes. So the answer to this one is true. It is a bit complicated, but it is true. And finally, 4 is not a prime factor of 8. Now, is 4 a factor of 8? Yes, we can divide 8 by 4 without a remainder. But 4 itself, is it a prime number? No, we can further divide 4 by 2. So the answer to this is that while 4 is a factor of 8, it is not a prime factor of 8. So that statement is true. 4 is not a prime factor of 8. So we looked at this video here, factors and multiples. In this video, we considered factors and multiples of other numbers. And this brings us to the end of video 3 out of 4 videos based on objective 1 from section 1.